Hello everyone, my name is Julien, I'm from Belgium. I'm not a scientist, nor a teacher, I'm just the speaker. And I'm going to present the Belgian expert synthesis on students' motivation for chemistry. Those experts train chemistry teachers at the University of Louvain. So there are first European observations. The youth disaffection for science in general and for chemistry in particular is widespread. The situation is worrying. At the University of Louvain, for instance, 120 students graduated in chemistry in 1972, while there are only a dozen of them now. There are two categories of causes evoked. First, society-related causes. Up to the year 70, science and chemistry were considered as factors of progress. The opinion turned after a period of disillusion. Science was no longer considered a source of progress. Environmental concerns, which are legitimate, have taken precedence and the image of chemistry was tarnished. It must be pointed out that sustainable development and chemistry are not mutually exclusive, but this idea is not easily accepted by the public. There's much disinformation, such as the opposition between chemical and natural product. It seems that society shows more consideration for doctor, economists or managers than for chemists or science teachers. Then the subject-related causes. Chemistry is considered as difficult. In secondary schools, chemistry teaching is too theoretical. There's little space and time dedicated to experiments, and yet chemistry, before anything, an experimental science. This is partly related to the lack of laboratory sessions and equipment in many schools, and the methods used are little appealing. The nomenclature is often learned by heart, teaching lacks of context, and unlike in physics or biology, chemistry does not seem to involve a great challenge. Then the expert observation. Despite all the promotion initiatives, such as from university and the industry, the number of chemistry students in higher education isn't increasing. In secondary education, many teachers are often helpless. There's a STEM teacher for biology, physics, and chemistry. There are security-related worries, and the class groups are too large. And there are too few experiments. So what should be done? Teaching chemistry poses problems. One has to be imbued with chemistry to understand those problems. Only those who have really assimilated the sense of chemistry will be able to validly learn it. Those who have renounced, thinking that they wouldn't understand anything about chemistry, cannot and will not be interested. According to the expert Bernard Tino, one of the authors of this report, chemistry, the science of matter transformation, raises two great questions. The first one, with what, that is with which reagents, and in which conditions can I make the product X? If teachers do not pay attention to the problem of jargons, of symbolism, and of chemist language in general, they will answer this question by writing an equation with formulas without explaining why this symbolism is used. The student will very soon be led to chemistry on paper. Chemistry will seem too hard and meaningless. It must be noted that many students who start the first year at university mix up reality and formula. The remedy is clear. We must go back to experimentations. And then the second question, being aware of the recipe, how much A and B should I use to make 10 kilo of the product X? The problem here is human. We have always liked seeing what we play with, yet atoms and molecules are too tiny to do so. We have to imagine the microscopic world. We cannot comprehend it or grab it. The change of scale that appears when introducing the concept of mole as a unit of quantity of matter is not clearly explained. and the comings and goings between the microscopic and macroscopic world are not numerous enough. Besides the complexity of the language, teachers are confronted with those two difficulties when the fundamental basis of chemistry are addressed, that is in second grade in Belgium. It's probably too early, at least the modeling aspect, when one considers the cognitive and psychological development of 16-year-old students. This results in a reaction of reject. Third point, the new ideas for remediation. To integrate more experiments in the class, greater means are necessary in terms of equipment and infrastructure, and in terms of training of the teachers. In this regard, some initiatives are taken, such as continuing training, a new frame of reference for skill, and then specific preparations for higher studies in chemistry should be created. In Belgium, there is no prerequisite to study chemistry at university, unlike for medicine, for instance. And to associate the use of ICT, experiments, and a systemic approach. These are realistic ways to see and make, or even better, to build experiments. Now, the analysis of the sources of motivation and demotivation in the school context. The educationalist Roland Viau proposes a list of practical advice to motivate students. They can be put in the context of a chemistry course. First, not to harm students' motivation. It's in the teacher's best interest to be aware of personal features that might harm students' motivation and to try to counteract the negative effect. First, the teacher should master his subject. As I've just said, in science education in Belgium, there's the same teacher for biology, physics, and chemistry, and not all teachers are trained as chemists. To adapt the subject to the students, because the gap between the academic knowledge taught in universities and the school subject can be huge. To define the contents. In the laboratory, the substances used are foreign to the students. Chemical phenomena known to the students, such as meat cooking, are often too complex to be accessible to them. Provide examples and analogies. Chemistry uses real objects that cannot be perceived by senses, such as atoms, molecules, and ions. Moreover, these objects are more numerous than anything the student could comprehend. And be willing to teach chemistry. The work of teacher nowadays is particularly focused on learning and requires a people-oriented profile. Being interested in inert matter is not enough. Second point, to improve one or several aspects of teaching to increase students' motivation. The teacher should bring students to make connections between what they know and the new subject, solve problems that will help them better understand the reality around them, play an active and dynamic role, propose activities for assimilation, propose activities for integrations, and use assessments to influence motivation. ICT and systemic approach to chemistry. It emerges that chemistry is an unusual subject, that it's delicate to learn. Given the evolution of knowledge societies and of school public, including its motivation sources, teachers find themselves with new constraints that require a change of professional attitude. The analytical process needs to be completed with a systemic approach to learning, by making it possible to dynamically model the microscopic universe. ICT participate in this transformation. Therefore, teaching sequences on chemical concepts that are particularly difficult to teach and learn, associating ICT and a systemic approach, will be proposed and tested in Belgian secondary school classes that are partner to the European project. Their impact on motivation and thence on students' learning will be assessed. This European project, Chemistry is All Around, aims at optimizing the learning of chemistry, making available to teachers existing ICT resources and newly created learning sequences on the project portal. The conclusion: Chemistry is a particularly complex science in which beginners need support from an expert in order to master the scientific jargon, master it through experiments, and master it through the use of ICT. And thank you for your attention.